Hi everyone, in this video I'm going to be working through a grade 8 maths exam. This is kind of what you can expect for your June exams. I really hope it helps you, but if you do have any questions, let me know in the comments. Let's get straight into it. So you can see this is an hour-and-a-half paper, and it starts off with some multiple choice. We are allowed to use calculators, and we must round to 2 decimal places. Okay, let's have a look at the multiple choice. So first of all, the lowest common multiple and the highest common factor of 27 and 36 are. So there are a few ways to do this. You could write down all the factors of 27, all the factors of 36, and write down a few multiples of each. It doesn't matter how you do this one. Usually my method is I do the prime factor tree. I just find that's the quickest. So I would say 27 and 36. Let's break these down into prime factors. So 27 is 3 times 9. And 9 we can break down and say that's 3 times 3. We circle all the prime factors. And so we can say, okay, 27 is the same as saying 3 times 3 times 3. 36, I would say, is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So we're just breaking these down and then we're circling all the prime numbers. And so we can rewrite 36 as 2 times 2 times 3 times 3. And then the really straightforward method for getting your LCM and your highest common factor is your LCM. Let's just get some space here. Okay, lowest common multiple. What you do is you're going to take the factors like this. So we're going to say, okay, we have 3 here and a 3 there. So we're going to put a 3 in there. 3 here and a 3 here. So we're going to put a 3 in there. And then you have to put all the remaining ones. So we've also got a 3 here. And 2 and 2. Okay, so the lowest common multiple, you take all the factors, but you don't duplicate. So if you've got a 3 in both, you don't write it twice. You should get a pretty big number. That's the point. That multiple is usually a big number. So 3 times 3 is 9. 9 times 3 is 27. 27 times 2 is 54. 54 times 2 is 108. And then if you want your highest common factor, how we do highest common factor is we only do the factors that are common in both. So here we've got a 3 in here and a 3 in here, a 3 in here and a 3 in here. And that is the only ones that we have in both. And so our highest common factor is going to be 9. So for this one, our LCM is 108. Our highest common factor is 9. So our answer is C. 1.2, a factory makes 5,000 cell phones per week. How many cell phones would they make if they increase production by 50%? Let's look at what 50% is. So 50% of 5,000. Okay, you could probably see that straight away. So 50% is half. So what is half of 5,000? It is 2,500. If you didn't know that, what you can do whenever you work out percentages is you're going to say 50 divided by 100 times by 5,000, and you put that into your calculator, and you're going to get 2,500. Okay, so that is 50%. So if they increase production by 50%, that means they're going to make the 5,000 that they usually do, and they're going to add on this 2,500. So in total, they're making 7,500 frames every week, which is D. Question 1.3, calculate -18, add 6, minus 10. Okay, these are all adding and subtracting, so we don't have to do it in any specific order. I'm just going to go from the front. So minus 18, add 6, that is going to be -18, add 6 is going to be -12, minus 10, minus 12, take away another 10, it's going to be -22, which is C. Question 1.4, the rule for the input and output values that are represented in the flow diagram below is, so what I do, I'm just going to test a few, and I find it easiest to start with the positive numbers. So 5, do something, gives you 11. So that one is add 6. Let's just check it works for the others. 3, add 6 is going to give me 9. Yeah, that's right. 1, add 6 is going to give me 7. So yeah, that is our rule. So it is always all inputs add 6. So here we can see output is inputs add 6. So this is going to be B. 1.5, the following verbal expression is given. Subtract a number from the product of 3 and that same number. Okay, so products of 3 and that same number. It just means like 3x. That is a product of a number and 3. We're going to subtract the same number from it. So that means we're going to take away that same number. That is what it's supposed to look like. Okay, they've used y here, so it's just going to be 3 times y take away y, which is D. Okay, that's all multiple choice. Now we are getting into the slightly longer questions. 2.1. State whether each of the following statements is true or false. So 0 divided by 86. So this part, 0 divided by 86 is just 0. 86 divided by 0, we can never divide something by 0. That is always gives us undefined. It gives us an error. So we can't say that these are equal. So because this side is not equal to 0. So that statement is false. One side is 0, the other side is an error. And then this part, let's see, 10, add the brackets, so 5 and 12 is 17. 10 add 17 is 27 on this side. On the other side, we've got 10 and 5 is 15, add 12. 15 add 12 is 27. So both of these sides add up to 27. So this is true because they are equal. Question 2.2, simplify the following, show all your calculations. So they're just checking if we're going to follow our, some people call it odd math, some people call it bid math. We want to check we're doing our order of operations. So we always have to do brackets first. So let's do these brackets. 15 add 20. So 20 add 10 is 30, add 5 is 35. So 35 and everything else stays the same for now. So we've done our brackets, we don't have any exponents. Next up we have to do division. 35 divided by 7 is 5. Take away the 2. And 5 take away 2 is 3. (2.3) Tabo, Silas, and Jacob are paid a total of 1,500 rand for the work that they did. They decide to share their amounts in the ratio 6 to 5 to 4 respectively. How much of the money will Silas receive? Okay, so let's just get this ratio down so we can see what we're working with. So it's Tabo, Silas, and Jacob. And they decide to do the ratio of 6 to 5 to 4. So with a question like this, what you want to work out is we have the total, we need to divide it by how many parts we have. So the total number of parts here, 6 and 5 is 11. 11 and 4 is 11 and 4 is 15. So we can say there are 15 parts. So what we want to do is we want to work out 1,500 Rand divided by 15 parts. Okay, so 1,500 divided by 15. We can see if we go 1,000, if we go 15 times 100, it gives us 1,500. So that is going to be 100. Okay, so this 100 is 1 part. We want Silas. Silas has 5 parts. So for Silas, we're going to do, so he has 5 parts. So we're going to do 100 times 5. So Silas is going to get 500 Rand. Question 3, state whether each of the following statements is true or false. Okay, so what I would do is I'm going to work out both sides and then you check if you get an equal answer. Are both sides equal? So on the side, we always do brackets first. So we're going to do this 2 add 1 first. So that 2 add 1, that is going to be 3. Okay, we always do brackets first. And so then it's going to be minus 5 times 3, which is minus 15. On this side, again, we do the brackets first. So this is going to be minus 5 times 2, so that's negative 10. For this bracket, minus 5 times 1, so that's negative 5. And then negative 10, add negative 5, a plus and a minus makes just a minus. It's going to be minus 10 minus 5, which is also going to be negative 15. And so we've got negative 15 is equal to negative 15. So these statements are true. They are equal. At the bottom here, let's get a different color. We've got x times minus 1. So x times minus 1 is going to be minus x on that side. On the other side, minus 1 times x, again, that is also minus x. And so we get that these are again equal. So this is also a true statement. At 3.2, simplify the following, show all your calculations. So we got negative 14, add 5 times negative 8. They are checking if we can use our, some people call it BODMAS, some people call it BIDMAS, whatever you call it. They're checking we remember to use this. So we always need to do brackets first. So let's work out this bracket first. Minus 14, add 5. So if we're working on a number line, it's going to be minus 14. And we jump 5 spots, so minus 13, minus 12, minus 11, minus 10, minus 9. Okay, minus 14, we add 5, that is going to be negative 9. Okay, so that's what that bracket becomes. So then we've got negative 9 times negative 8. A minus and a minus, if you're timesing it, minus times a minus makes a plus. Then 9 times 8 is 72. And then if it is plus like that, you can just write 72. 3.3, the sum of two numbers is negative 2. Their product is negative 24. What are the two numbers? Okay, so we need two numbers. If we add them together, we get negative 2. If we multiply them, we get 24. So this is what I'm going to start with, is the product. So the product is 24. So let's see, what numbers can we multiply to get to negative 24? So if I were to say 2 times negative 12, that would give me negative 24, for example. Also, 3 times negative 8 will give me negative 24. What else could we do? Factors of 24, so it's 2, 3, 4, yeah, no, 4. Okay, so I think it's probably going to be these ones. We could also do 1 times negative 24 gives you negative 24. So you're just kind of playing around with these. These are all the products. Now we're going to see if I add any of these numbers together, will I get negative 2? I think we've actually missed one of the other ones, because we could also do 4 times negative 6 would give us negative 24. Okay, so the negatives could be on either of these numbers, but I'm just putting it like this for now. We're going to now play around and see if we add any of these together, these factors, can I get then this sum? So they say the sum of the two numbers is negative 2. So that means if I were to say 3 add negative 8, what would that give me? So 3 add negative 8. That means 3 take away 8. So that's going to give me negative 5. So not that one. It's not going to be 1 and 24. 2 add the negative 12 is going to give me negative 10. Let's try this. 4 add the negative 6. That is going to give me 4 take away 6 is negative 2. So that is actually the right one. So the sum of the two numbers is minus 2. We've got that. So yeah, I have summed the numbers and I get minus 2. The product of the numbers is negative 24. Okay, so these are the two numbers. So the two numbers, it is 4 and negative 6. So you can see this one, it takes a little bit of fiddling around, a little bit of testing out. But that's how I would do it. Write down as many factors as you can. See if you can fiddle around and get to negative 24, and then see if you can add them and get to negative 2. Question 4. Common and decimal fractions. So simplify the following. Show all your calculations. Okay. With fractions, my first step is always, if there are mixed fractions like this, where they've got a whole number and a fraction part, my first step would be to make them into just improper fractions. Okay, so that is always my first step in this, is convert all the mixed numbers to improper fractions. Okay, so these ones in the front's fine. I'm just going to do this negative 2 and 5 over 5. So negative 2, oh, we don't have to actually worry about the negative right now. So 2 and 5 over 5. So how we convert this is we always go the big number times the bottom. So 2 times 5 is 10. Add the top number. So 10 add 5 is 15. And the base always stays the same. So 15 over 5. Okay, now we can rewrite this here as 9 over 15. Add 2 over 3. Take away 15 over 5. Your next step is, once you've converted them all to improper fractions, you need to make all the bases the same. So convert to equivalent fractions, which is just a fancy way of saying make all the bases the same. Okay, make all the denominators the same. Okay, so what I would do here is I can see I've got 15, and then this 3 goes into 15, 5 goes into 15. So I'm going to make them all have a denominator of 15. So this is just going to be my where I do my conversions here. So 9 over 15, that one is fine. We don't have to convert that at all. 2 over 3, we need to convert that to something over 15. It's really straightforward to do the conversion. We just have to see what did I do to the bottom. So 3 times 5 will give me 15. So at the top, I'm also going to times it by 5. 2 times 5 is going to be 10. So that one's going to be 10 over 15. And then I've also got to do that last fraction. So I had 15 over 5. What do I do to the bottom here to get it to 15? So I would have times that by 3. So 5 times 3 gives me 15. At the top, 15 times 3. 15 times 3 is 45. Okay, now this is looking a little bit better. We've got 9 over 15. Add this 2 over 3. We said we're rewriting it as 10 over 15. Take away 45 over 15. So we can see now they all have the same denominator. They all got the same base. So now we can just add the tops. We keep the bottom the same. So the bottom is going to be 15. At the top, we got 9. Add 10 is 19. 19, take away 45. That's what we're working out. I think we are allowed calculators in this. Let's just check. Yeah, calculators are allowed. Okay, so we got just do 19 take away 45. Okay, 19 take away 45. It's going to give me negative 26 over 15. And then with the fractions question, make sure your final step should always be converted back to mixed numbers. So that is your final step. So convert your answer to mixed numbers. Or mixed fraction. Sorry. How we do that is we always say how many times does 15 go into 26? So 15 goes into 26 one time. How many leftovers are there? So there would be 11 leftovers, and we always keep the base the same. So this is our final answer, minus 1 and 11 over 15. Okay, 4.1.2 is a decimal question. So with the decimal question, they always make it look scary because here we've got 3 decimals, 1 decimal, 2 decimals. It doesn't matter. When we write them out, we're just going to make sure we have the same number of decimals. So let's do this part first. Okay, so it's going to be 7, 86, add 3, 7. I just added 0 where there's nothing. Let's add these. So 6 add 0 is 6. 8 add 7 is going to be 15. Carry the 1. 1 add 7 is 8. 8 add 3 is 11. We got 11.56. Then we are going to take away that 4.999. So 11.56. Take away 4.999. We don't have anything there, so we're going to put a 0. 0 take away 9 we can't do. We're going to borrow it from here. 10 take away 9 is 1. 5 take away 9 we can't do, so we're going to borrow again. 15 take away 9 is 6. 4 take away 9 we can't do, so we're going to borrow again. 14 take away 9 is 5. 0 take away 4 we can't do. 10 take away 4 is 6. And that is our final answer there. 6,561. So they're trying to make it look scary with all these decimal places, but just make sure you line up the decimal places nicely. If there's a missing space, you just put a 0. Question 4.2. Elvis spends 21 out of 200 of his pocket money on chewing gum, 0.546 of his pocket money on a pair of shoes, and 28% of his pocket money on a present for his mom. If Elvis gets 300 Rand for pocket money, what percentage of his pocket money does he have left? Okay, so what we need to do is we need to work out all these different parts that they've told us. We do have a calculator, so it's not too difficult to work these out. Let's just work out step by step. It is nice when it's a 3-mark question like this because there's lots of chances to get marks. So first of all, let's do this part. So this is what he spends on chewing gum. Okay, so 21 out of 200 of his pocket money on chewing gum. The total is 300. So we're going to work out 21 out of 200 of 300 Rand. How you put this into your calculator is you are going to say 300. No, sorry, we're not going to say 300 to start. We are going to say 21 divided by the 200. So top divided by the bottom. Of means times, so times 300. And we're going to work that out. So it's nice, we've got our calculators, so we can just go 21 divided by 200 times 300. So he spends 31 Rand and 50 cents on chewing gum. Let's work out the next part. So he spends how much on shoes? So 0.546 of his pocket money on shoes. So we are just going to go 0.546 of 300. So that means that times 300 of boys means times. So when you see of, you just times it. So times. So 0.546 times 300 is going to give me 163 and 80 cents on shoes. And then finally, 28% of his pocket money is on a present for his mom. So we need to work out 28% of 300. How we do this is this 28%, this percentage symbol should be your reminder that you go 28 divided by 100. It kind of looks like a divide sign. So 28 divided by 100 times the 300 Rand. It's going to give us how much he spends on his mom's present. So 28 divided by 100 times by 300 is giving me 84 Rand on the present. And then what percentage of the pocket money does he have left? So first of all, we're going to work out how much does he have left. And then we can work out the percentage. Okay. So left, he had 300 Rand. Then we're going to take away the money for chewing gum. Take away the shoes money. Take away the present money. To get how much he had left. So that is 300. Take away 31 Rand 50. Take away 163 Rand 80. Take away 84. He's left with 20 Rand and 70 cents. What percentage is that? How we work that out is we say the percentage is the 20 Rand divided by the 300, the total. So the leftover amount divided by the total times 100 will give us a percentage. So that divided by 300 times 100 it means 6.9%. That is his leftover percentage. Question 5 is exponents. So first they say match column A to column B. Okay, so let's just work these out. So this one, 6 squared is 36. And 2 to the power of 6 means 2 times 2 times 2 times 2 times 2. So it's 6 times, like. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 1, 2, 3, 4, 5 times 2 is going to be 64. And then on the other side, if we work them out, 2 squared, so that is 4, times 2 squared, which is 4, times 2 squared, which is 4. So 4 times 4 is 16, times 4 is 64. So that is going to be the same as this one. So 2 to the power of 6 is 64. So this one, I don't think that's going to work like that. We have to write it like this. So 2 to the power of the 6 is equal to 2 squared times 2 squared times 2 squared. And then if we work out this other one, 2 times 3 is 6. 3 times 3 is 6. So 6 times 6 is 36. That's this one. 2 times 3 times 2 times 3. Simplify the following. Show all your calculations. Okay, so in this one, first of all, we're going to have the cube root, 127 take away 2, so we can work out what's in there. So it's going to be 125 times -5 squared. So if the negative is inside like this, it's going to be actually -5 times -5. Okay, we can then simplify. So the cube root of 125, you do have a calculator with you, so you can check, but the cube root is always just 5. Because if you go 5 times 5 times 5, it gives you 125. Times, okay, so -5 is going to give us +25. Okay, and this part here, if we square -5, it always just gives us 25. And then 5 times 25 is 125, which is our final answer. Okay, Jolene remembers her teacher saying, when you divide powers, you subtract the exponents. So Jolene simplified this m4 over n6 as follows. Okay. What is the question? So you always need this difference. So this 4n is the really important thing. So what we say is, for the general term Tn, we go 4 times the number, so the number of the sequence. Then we just need to figure out what's missing. So if I say the first term, so T1, term 1, 4 times the first term gives me 4. And then I need it to be 1 square. So I'm going to subtract 3 to get the 1. Let's check if that works for the second term. So term 2 is going to be 4 times 2, which is 8. take away 3 gives me 5 squares. Okay, so this is looking like the right one. For the third sequence, I'm going to go 4 times 3 is 12. Take away 3 is 9 squares. Yeah, so this is the correct general equation. So I'll just put it here so we know. So for any term, Tn, it is always 4 times the number of the pattern, take away 3. Using an answer from question 6.1.1, determine the number of squares that will make up pattern number 6. So we want T6, so it's going to be 4 times 6, take away 3. So I'm going to check that's right. Yeah, take away 3. So 4 times 6 is 24. Take away 3, which is 21 squares. Which pattern number will be made up of 1025 squares? So in this case, we have the answer. And we are trying to work out which number it is. So first of all, we're going to take the 3 across. We were subtracting the 3. When we take it across, we're going to add the 3. So 1025, add the 3. That is going to be 1028 is equal to 4n. We want n by itself. So we were timesing by 4. We're going to take it across and divide by 4. Let's work that out quickly. So that is going to be 1028 divided by 4 is 257. Okay, so pattern number 257 will have 1025 squares. Okay, and then we've got an equation here. Y is equal to negative x squared plus 2. And we've got some missing. Complete the table by writing down the values for A and B. Okay, so A is this here. So when we put in x is 1, what do we get for our y? Okay, so we're going to say y is equal to minus x squared plus 2. In this case, we know that x is 1. So y is equal to minus 1 squared plus 2. So 1 squared is just 1. So it's going to be minus 1 plus 2. So that is going to be positive 1. So A is equal to 1. And then next, they want us to work backwards and find B. So when y is negative 34, we got to work out x. So we're going to say negative 34 is equal to minus x squared plus 2. First, we're going to take the 2 across. So it's going to be, we were adding 2, now we're going to subtract 2. So negative 34, take away another 2 is negative 36 is equal to negative x squared. We can cancel the minuses on both sides. So x squared is equal to 36. We can then square root both sides. And so we can say x is 6. Okay, so that means B is going to be 6. Okay, question 8, algebraic expressions. Answer the questions related to the following expression. 2a minus 4a squared minus 8a. So are the terms 2a and minus 8a like or unlike terms? They are like terms because they have the same power. So they both have a to the power of 1. Okay, because if it is 8a, it's the same as writing 8a to the power of 1. 2a, the same as writing 2a to the power of 1. So if they have the same base, a, and the same power, then they are like terms. Write an equivalent expression for this. So an equivalent expression would be, we could simplify it a bit and say 2a take away 8a. So 2a take away 8a. So 2 take away 8 is negative 6a. And then we can't do anything with that squared term, minus 4a squared. This is an equivalent expression. It's just simplified. I suppose what you could also do is you could also potentially take out like minus 2 as a factor here. You could say minus 2, 3a plus 2a squared. You could do as well, but I think this part would be enough just to simplify it like that. Determine the value of the expression if a is equal to minus 1. Okay. So you can choose if you want to use this equivalent expression or if you want to use the original expression in this question. I'm just going to use the original just in case you made a mistake and you don't want to use the wrong one. So let's use that original. 2a minus 4a squared minus 8a. Okay, and they say we've got to do it when a is minus 1. So wherever there's a, we're going to put minus 1. Okay, so 2 times minus 1 is minus 2. Minus 4. Minus 1 squared is just going to be 1. Minus 8 times minus 1 is going to be positive 8. So we're going to have minus 2, minus 4, plus 8. Minus 4 minus 2 is going to be negative 6, plus 8 is going to be 2. Simplify the following expressions fully. Okay, let's have a go. So minus x squared, if you have it like that, we're squaring the negative sign, so that is just going to be positive x squared. Plus b minus x squared minus the square root of b squared. So the square root and the square cancel. So that's going to be minus b. And then we've got x squared minus x squared. So those are going to cancel. B minus b, those are going to cancel. And so our final answer for this one is just going to be 0. So this one, they were just checking if you could do that cancelling of the root and the square root, and if you could get that to be a positive number. 8.2.2. Okay, so they want us to multiply out the brackets and then simplify. So this one's going to be minus 6 times 3a. So that is going to be negative 18a. Minus 6 times minus 2b. A minus and a minus makes it positive. 6 times 2 is 12b. Add the 6a. Take away the b. Now we're going to do the like terms. So let's do the a terms first. So negative 18a add 6a minus 18 add 6 is going to be minus 12a. And then we'll do the b terms. 12b take away b is going to be 11b. And that is as far as we can simplify that one. And then is that everything? Yeah, that is everything. So then we just got the memo. I really hope that video helped. I will post the link to this in the description as well, along with the memo. As I said, I hope this video worked. It helped you revise, helped you see what you need to work on. If you do have any questions, please feel free to let me know in the comments, and good luck for your studying.